Hi everyone. Great to be here. Very excited to be here in this amazing city of Raleigh. My name is Aviram Shmueli. We're going to talk today about infrastructure as code scanning and how to leverage AI for remediation. Because scanning, just alerting is not enough. There must be something with AI that can be leveraged to provide remediation for everything that we find in infrastructure as code scanning. So I'm a co-founder at JIT. We develop a complete DevSecOps platform for modern engineering teams. I'm also a husband and father to 3 kids. My background is engineering development. I've been doing development for about 15 years. I've then transitioned to the dark side of product management, but I live and breathe cybersecurity. I've been doing cybersecurity for the last 25 years, both as an attacker and on the defensive side. So I had the privilege to enjoy both aspects of cybersecurity. You know, infrastructure as code has revolutionized our life as DevOps people. It provides speed and efficiency and consistency and reliability and scalability, right? This automation is amazing. It can reduce cost, and since the infrastructure as code is managed in the SEM as code, it provides out-of-the-box documentation and version control. And also, it provides an improved security. Because there are security risks and their misconfiguration with infrastructure as code. For example, access controls and lack of encryption and insecure configuration and issues regarding firewall and networking. There are many issues with infrastructure as code. And this is why there are great open source solutions out there that we recommend DevOps people to use. They will scan your infrastructure as code as part of they will scan the existing code base or the pull requests, and they will provide a good quality of detections. I'm talking about Kix by Checkmarx, Checkov by Palo Alto, and Trivri by Aqua, formerly known as TFSec, now known as Trivri. Those 3 tools, they perform very good job in detection of infrastructure as code issues. Let's take just a few examples. So in this case, do you see the misconfiguration in here? Yeah, basically, this piece of code allows SSH connection from the entire world. So if you run Kix on it, it will detect this security group as misconfigured. It will provide relevant lines of code which introduce this misconfiguration, and it will provide more description about its misconfiguration. Let's take a look at another example. In this case, we create an EBS volume, but with no encryption. You see that the encryption part is commented out, right? So the EBS volume will be created with non-encryption in place. So if we will run Trivri, for example, other tool, it will find this is an issue, and it will flag out that the EBS is not encrypted, and it will advise to do that. The third example is about IAM policies that should not allow permissions, overly excessive permissions. And in this case, you see the effect allow and the resource which allows all resources. And that will be considered as an issue by Checkov. Okay? And Checkov will provide, again, the description, the relevant lines of code, and the recommendation. So if you think about it, those 3 security tools perform really well, and we recommend DevOps people to use them. They provide good detection efficacy. They do not provide remediation. Kicks, they started to do some work about remediation, but it's not comprehensive. But basically, those are detection tools, not remediation. In order to make those tools into your production environment, you may need to have some ability to exclude paths and libraries, to exclude some queries. For some users, not all queries are equal, and you'll need to exclude some severity. So all of these are supported by those tools, by some of those tools, but in general they are supported. All of them are maintainable, meaning when I prepared this deck and I was looking in GitHub, all of them were updated in the last 48 hours. So people are working and maintain those projects. They are very popular, and the license model is permissive, so it's great to use them. However, it's not enough, because those are basically detection tools. But in order to make them to production, you need also to add a layer of remediation, because getting alerts is just not enough. We need to help our engineers to create more efficient security by providing them remediation. So also prioritization and context is important, because many times the vulnerability or the misconfiguration itself is just not enough. You need to understand the entire context of the project, and for example, whether it's deployed to production, in order to decide whether to elevate the risk score or not. So just misconfiguration by itself is not enough. Those tools also, you need, in order to make it production grade, you need also to make sure that developers would love to work with kind of tools. So they need to get integrated into the developer workflow. So anyways, in order to make those tools into production, there are a few other layers that should be added. So how can AI help us? AI is, an amazing capability that we were exposed to in the recent years, and we can use AI to improve detection efficacy, or to understand the context and to do better prioritization. We can also use AI for remediation, and we'll touch it in a minute, and also for training and awareness. So it's not that just limited to remediation, but in the next few slides, I'm gonna show you how we and how the community can use AI in order to create remediation for infrastructure as code misconfigurations. That will take those security tools into the next level. So just to agree on terminology, we're defining a finding type as a category of vulnerabilities. For example, lack of encryption or SQL injection. Finding is a specific occurrence or instantiation of a particular finding type. And remediation recipe, is a format of a recipe which includes instructions how to remediate an issue. So just to define the problem, we want to have a way to know how to remediate an infrastructure as code misconfiguration automatically, which is pretty amazing. So in this example, you see that there is an S3 bucket which is defined here, but it has no encryption. So we would like, ideally, that an AI solution would tell us, hey, this S3 bucket is not encrypted. Here is a snippet that you just need to edit, and it will make this S3 bucket encrypted. So, for example, to switch between line 14 to the rest of the section. So we built a machine that knows how to generate those remediation recipes. It takes code samples that we found out there, and we also generated some of them automatically. It takes a finding, meaning an example of how a specific finding looks like to help the engine to understand what's the structure of a finding. We also fed this machine with a recipe format that includes the first part of this should be a JSON, the first part it should be a code, and then some textual description. So we had to provide the AI engine some description of in what format we want to have the remediation. And then we also created an elaborative prompt because we believe that no such thing is too much information with AI. And then we ran this machine 600 times for each finding type that we had. We got results, meaning a remediation for each finding. However, we wanted that someone, human being, will review them to make that a curated list of remediations. This is why we fed all those remediations. We fixed with the remediation those findings, and then we fed them again to those scanners. We made sure that the scanners now believe that the issue was fixed. So this was a way for us to validate the remediation actually works. So we did it with the findings that we detected by kicks, and we fed all the findings that we found. We got more than 200 recipes, okay, with an average generation time of 2 to 5 minutes per recipe. And after we did the validation, we got a result of 85% of accuracy, meaning remediation recipes that we believe that are great and that they make the job. So let me show you some examples. In this case, you see an EC2 instance that has a public IP address. Okay? So we see that the remediation engine automatically generated this remediation. Remove line number 6, which said associate public IP address equals true. This was done automatically by the remediation engine. You see that the structure or the attribute of this remediation is remove a line or remove a section. This is one type of a way to do remediation. There are other types that we'll see next. But this type of remediation talks about removing lines which pose a problem. The other use case is about security group which allows unrestricted access to SSH. In this case, the security tool detected the 0.0.0.0, right, from the entire world. So the remediation engine conclusion was to offer you to switch this subnet to other that will define your own range, IP range. In this case, it cannot just replace one value with another because it doesn't know, but it can tell you, hey, you need to pay attention and to replace this CADR with a different one. So in this case, the type of remediation is replacement. It's not just about removing a line, it's about suggesting a replacement. The third example is about encryption. In this case, you can see that the remediation engine decided to add a new block to an existing code base. So we had removal and then switch a value. In this case, the remediation type is different. It's about adding more code to the code that you already have. And in this case, the S3 bucket that will be created while it has server-side encryption. Okay, so my takeaway. So we believe that infrastructure as code scanners are amazing, and they can identify gaps in infrastructure as code. They will detect compliance issues, misconfigurations, security issues. And the tools that we have today out there in the market and the open source are great. We talked about Kix, we talked about Trivi and Chekhov. They do great detection. And even Kix started to do some remediation. But we believe that the next step, and we believe that the community is ready to have remediation out of the box, not just about alerting, because we cannot manage with this backlog of alerts. We need to help our engineers to do remediation and actually to fix those issues. This is why we decided to enhance AI, and we created this machine that enables us to generate hundreds of remediation recipes of all sorts and kinds, to actually remediate all the issues that we see that are related to infrastructure as code. But it's important to mention that it's not that we decided just to run AI and that's it, and we trusted that all the results were amazing. We did a curation process where a human being reviewed each and every one of those recipes just to make sure that they work as expected. And the way for us also to make sure that they work was to fix those issues and then rerun the scanners over again and make sure that they do not find those findings anymore. Okay. What we did with Kix is only one part of what we do at JIT. We orchestrate a wide breadth of security tools, including Kix and many other, covering the entire software development lifecycle. We are part of the open source community. We contribute back to the community. We contribute rules and more detection and remediations, and we sponsor some of the projects. Eventually, whenever we develop a security tool, it's important to make the developer experience amazing. Otherwise, developers will hate the tools and they will not use them, right? So this is why we believe that every product security tool should be embracing developers and encourage them to adopt this security tool. So with JIT, for example, we integrated with the IDEs and in pull requests and with Slack, for example, to make developers work in their own native environment without even signing in to JIT. Any questions? Sure.
How does this differ from a recipe perspective to the type of auto remediation that's available on platforms like Open Rewrite?
So
Can you restate that question?
Oh, I'm sorry.
Yeah, okay.
How does this compare to other auto remediation platforms from a remediation perspective, like a mechanical perspective, to something like Open Rewrite?
So I just want to mention, we're not talking about auto remediation, because the automation here is about generation of the recipes, but eventually we are not going to change the code. We will provide those suggestions to the user, and the user will eventually need to decide whether they're going to merge our suggestions to the code or not. So it's automated in a way that it was generated, but it will need a manual review.
That makes sense. Thank you.
Any other questions? No? All right. Thank you so much.
Thank you.